You're bitten by a venomous snake. No hospital, no antivenom, no phone. This is 50,000 years ago, and you're on your own. Snake bites weren't rare back then. They were routine. Early humans lived on the ground, slept on the ground, walked barefoot through grass they couldn't fully see. Some researchers believe snake bites were one of the most common causes of death for early hunter-gatherers, right up there with predators, infection, and childbirth. And here's the strange part. We survived it. Not every time, but enough. Enough that snake bites shaped how humans think, how we see, even how we move. So how did people with no medicine, no needles, no science actually survive a venomous bite? First, they had to know which snake could kill them, and that alone was a matter of life and death. Some scientists believe humans evolved a kind of built-in alarm system for snakes. Fast recognition. Faster than for almost anything else. Studies on infants show babies as young as 6 months notice snake shapes quicker than other objects, even before they've ever seen a real one. That's not learned. That's ancient. But recognition alone wasn't enough. Early humans had to learn the difference fast. Triangular head versus round head. Slow retreat versus fast strike. Bright warning colors versus camouflage. Knowledge like this was probably passed down obsessively, story after story, because one wrong guess could be the last mistake you ever made. And once the bite happened, everything changed in seconds. So what actually happened in the minutes right after the fangs sank in? The venom starts moving immediately. Some toxins attack the nervous system. Others destroy blood and tissue from the inside out. Without treatment, a person could lose consciousness in minutes, or bleed internally for hours. So what did early humans do? Some evidence suggests they tried to slow the venom down, staying still, not running, not panicking, because movement pumps venom through the body faster. Others may have tried sucking or cutting the wound, something modern medicine now says likely did more harm than good. Certain plants were probably used too, some with real anti-inflammatory properties. Others, almost certainly, just placebo. Hope disguised as medicine. The line between what helped and what didn't was often invisible to the people living through it. But here's what should be impossible. Some people walked away completely fine. Not everyone who got bitten died, not even close. Some snake bites are dry bites, no venom injected at all, just a warning strike. Some people had partial resistance, built from tiny, repeated exposure over a lifetime near snake territory. And bite location mattered more than almost anything else. A bite on a fleshy part of the leg spread slower than a bite near a major vein. There's another factor too, one researchers still study today: genetics. Certain populations that lived for thousands of years alongside dangerous snakes may carry subtle biological differences. Differences that could have meant the gap between survival and death. In other words, evolution may have been quietly picking winners. Long before anyone understood what venom even was. And this is where it gets even stranger. Modern scientists studying ancient remains have found something unsettling. Snakebite deaths may have been so common, they left a mark on human evolution itself. Some researchers argue that our sharp eyesight, our talent for spotting patterns in grass and leaves, might be partly a leftover defense system, a survival tool built by generations of near misses. Every rustle in the grass, every shadow that moved wrong, millions of years of humans staring just a little too long at the ground, just in case. We didn't just survive snakes. In some small way, they helped shape how we see the world. So next time a sudden movement makes your heart jump, before your brain even catches up, that reaction isn't random. It's inherited. From ancestors who didn't have medicine, only instinct. And just enough of it to survive.